Synchronous technology in Solid Edge is a direct edit type of modeler. Now, there's a lot of people that think that direct edit modelers are not parametric, but this video is going to show how Solid Edge with synchronous technology overcomes that. So as you can see, we have a model that is based on synchronous, so it's direct edit, and we can pick on a face and modify that. As you can see, the dimension value changes as we move it. We also have our design intent, which picks up relationships to define how the other geometry is going to be affected. So just to confirm the concept that this is a parametric drawing, we can pick up on this dimension here. We have the option of which direction we want to move the face. So at the moment we're going to push it out further, so we can change that value, and we can see the geometry change. What we also see is that other faces have changed as well. So that sort of shows that we can drive the model through dimensions, which is sort of the definition of parametric. But it can also take you further than that. So you saw that this face here moved. We can click on this dimension here and lock that value. That means that that dimension will now not change. And you saw that the gap between the holes and the outer face increased as well. If you decide that you want to move those holes, I've just dimensioned them there for reference. What we can also do is actually select that whole area and use our dimension here to drive that whole series of components. So we're still working under that guise of a parametrically designed part, but we have the flexibility of configuring items that are actually in different features, mapping well together. Another way that we could do the same thing is again to lock these dimensions, and as we change this value here, you'll see that because they are now locked, they have to be maintained. So we have a good level of control of the model. Now if we unlock this value, you'll see that we can, as I showed, adjust this face here, and you'll see that it thickens that end face. So in a 2D profile sketch, what you might do is have a dimension across here. We can do a similar sort of thing by defining a 3D face relate. So this defines how the model is going to behave. So it's recognized that there's a 75 mm spacing between the two faces, and we can change that or just accept it. So now over here we have a relationship that is defining the width of that end face. So now if we modify this value in here, you'll see that it is maintaining that offset. We can override that when we make our changes. So another advantage of synchronous technology is that when you design something, you may come across the requirement to basically change the faces on which geometry is created. So this part was created as a straight protrusion. If we decided that we wanted to have this pointing down, it could be a design change, or it could be a separate part. So we can use our fence selection again, and by repositioning our steering wheel on the center here, we can actually rotate this whole face around, say 90 degrees, to give us our new orientation of the part. So as you can see, Synchronous technology is parametrically designed and gives you far more than a traditional feature-based modeler.